Hey everyone, and welcome back. Before we begin here today, please make sure that you like and subscribe because it really does help us out. And it also helps us reach others in need of assistance with these topics. So what we're doing here today is that we're going to be covering calculus, and we're going to be using multiple rules in order to find a derivative. So this particular video, we are going to be using the product and chain rule together in a single problem. So let's get started here. We are tasked with finding the derivative of this expression shown. So what we're going to have to do is that we are going to have to use the product rule because we have two portions being multiplied together like this. So in order to use the product rule, we are going to have to set some variables. So what we are going to set is that we're going to set f equal to this first portion of 4 plus x to the power of 9. And then we are going to set g equal to the second portion of 2 minus x to the fifth. So pretty much whenever you have two portions being multiplied together, that's when you're going to use the product rule, and that's what we have going on here. Now, to utilize the product rule with these substitution variables, what we're going to have is we're going to have the derivative of our f times g, which is essentially what we have here is we've changed this for f and this for g, and it's going to be g times the derivative of f with respect to x plus our f multiplied by the derivative of g with respect to x. Well, these are not so terrible to figure out because we'll have to use the chain rule to figure them out individually, these individual derivatives. But writing all of this out, we would have g, which is 2 minus x to the power of 5, multiplied by the derivative with respect to x of our equation f, which we set as 4 plus x, 4 plus x to the power of 9, and then plus our f, which is 4 plus x to the power of 9, times the derivative with respect to x of g, which g is 2 minus x to the fifth. All right, well, now oh my goodness gracious. Now we can apply the chain rule to these derivatives because we can't solve these derivatives directly without using some kind of rule. So since we have some addition and subtraction going on inside the power, so what we're going to do is we're going to have to apply the chain rule, and we're going to get two parts. One for the first portion of the derivative of f with respect to x, and one for the derivative of g with respect to x. So applying the chain rule here, and we're just going to do these simultaneously. So our first one, we're going to have the derivative with respect to x, and it's going to be a 4 plus x to the power of 9. And our second one, which I'm going to write way over here, the derivative of x, or the derivative of g with respect to x, which is 2 minus x to the power of 5. So applying the chain rule, we're going to have to do some substitution once again. So what I'm going to do is I'm going to set u to everything within the brackets before the power is taken. So that'd be 4 plus x. And then I'm going to set h is just equal to that u to the power. And then very similarly over here on the right side, I'm going to set v equal to everything within the power, which is 2 minus x. And then I'm going to set m equal to v to that power of 5. All right, so that's the start of our chain rule. We have our parts written out. Now, having the derivative of h with respect to x would equal the derivative of h with respect to u, multiplied by the derivative of u with respect to x. So we end up with this d du multiplied by u to the, or d du of u to the 9th, multiplied by d dx of 4 plus x. And then my second portion over here will be very similar, just replace the variables. I'm going to have ddm, or dm over dx is equal to dm dv multiplied by dv dx. So this is going to be d dv of v to the 5th, all that multiplied by d dx of 2 minus x. All right, these are much easier derivatives to take. So let's work with the first one here. So the derivative of u to the 9th will just be equal to 9 u to the 8th, because all of these are now in the form of ax to the b, where that would be b times a, well, the derivative with respect to this is equal to b times a times xb minus 1. They're all in this form. Very easy to take the derivative of. And then my second part where I'm multiplying by, anytime you have a constant without the variable you're taking the derivative with respect to, it just comes out to be 0. And then whenever you just have that plain variable, it's just going to be the constant attached to it, which in this case is 1. So this first portion just pops out to be 9u to the 8th. Well, let's just replace it with u. Well, what is u? U is 4x, or 4 plus x. So this ends up being 9 times 4 plus x to the 8th. So that's my first part of my chain rule completely finished off there. What about the second one? Well, the second one is going to be d dv of v to the 5th. Well, that'll just be v, or 5v to the 4th. Multiplied by 2 becomes 0, and minus x becomes minus 1. So this simply becomes minus 5v to the 4th. Well, what is v? It is 2 minus x. So plug that in, of minus 5 times 2 minus x to the power of 4. All right, so now I'm going to take both of my chain rule substitutions, or solutions, and then plug them back up into the original equation up here. And I end up with a long expression of 2 minus x to the 5th, all that multiplied by my dh dx, which is 9 times 4 plus x to the 8th, plus 4 plus x to the 9th, all that multiplied by my dm dx over here, of minus 5 times 2 minus x to the power of 4. And if you simplify that down just a tad, not too much to do there, you end up with this expression of 9 times 4 plus 8, or plus x to the 8th, multiplied by 2 minus x to the 5th, minus 5 times 4 plus x to the 9th, all that multiplied by 2, or that ending part minus 2, or multiplied by 2 minus x to the 4th. A lot of variables and powers there. So that is your final answer, and you could simplify that further down if you wanted to. You could take this to the 5th and this to the 4th, that to the 9th and to the 8th, and solve it a little bit more if you wanted to, but that is good enough in my book. That is the derivative. So starting out, whenever you see two portions being multiplied together, you want to use the product rule. And then looking at this, whenever you have two individual portions, a 4 plus an x, or in this case, 2 minus x, basically two portions within this certain power, you want to use the chain rule. So this problem had the product rule being used first and then followed by the chain rule. And this is how you would mix rules. It's not super difficult if you know the product rule, chain rule, or the quotient rule. You just have to determine which one you are going to use first. So I hope this video was helpful. And if you want to see more problems solved this Friday, please check out the other videos on our channel. Also, if you haven't done so already, please like this video, leave a positive comment below, and subscribe to the channel because all of that does help us out. Thank you for watching, and I hope you have a great day.